All right, we're back. Every day. It feels like every day. Alex, how's it going? Here we are. Here we go again. Yeah, so today, planning to go over some of this kind of car tire burnout effects or whatever. I was just looking at some different references of that. Brandon, Julian, Alex, how's it going? Yeah, so we're gonna do try to just look into, or it's probably not gonna get finished today, but just start setting things up and doing some kind of R&D for some of this tire smoke stuff. So I think it was Billy on the Discord had shown this reference, I don't know, like a month ago or something. So, are they doing this Houdini battle right now? Is it going? Where is it? I didn't even realize that it was happening. Jack, how's it going? Very busy. Yeah, it feels like everyone's been pretty busy recently. Ooh, they're doing some buildings. This is like a spiked bat. Vegan nuts, how's it going? This looks like something, I don't know, this is like a rocket. Punk rocket. Ah, yeah, it's like kind of like a punk jacket. It kind of looks like the BDSM kind of stuff. They just started? How long do they have to, how long do they have? They started with 1 hour? Jeff, how's it going? 45 minutes. Well, how do you get, oh, I see Advino in there. How do, Mistaken Tuna, how's it going? Naranjos, we got a full house in here today. How do you go to get the split screen thing? Wasn't, with the last one there was like some command to get to do the POV of the other players. I'm doing all right, Jack. I was getting pretty busy myself. I'm trying to finish that grains tutorial as well, but I keep like, I'm trying to record it and not do a lot of editing on top of it, so I just keep like restarting the same recording, and then if I mess up, I just try it again. So I've just been kind of grinding through it right now. But I'm hoping to have it done by the end of this weekend. I finished, you guys saw some of that, yeah, it's hard to do it that way. There's not really a good way to do it. Like, if you do it with editing, then I feel like it just turns into a lot of work you have to do at the end to kind of cut stuff together, and it just turns into a mess sometimes to make it like flow that well. So I feel like this, even though it's going to be brutal one way or another, this at least gets you like into a pretty good rhythm, and you figure out like a lot of the kinks and stuff like that. You like to listen to the way you're doing it, but it's harder? Yeah, it might be harder on my end in terms of like just doing more reps and stuff, but personally I don't really like editing, and like sitting down and editing like several different takes of my own tutorial together would be a pretty big nightmare for me. So that's why I don't, that's why I'm afraid of doing it like that. Jack, thank you for cheering. I don't really know how the bits work. I appreciate it. So I was doing some more of these tests. My light right here might be a little bit odd. I don't know if it should be blurry or something, but the rest of this thing was pretty cool. This like color differentiation. Gotta go to sleep. Have a good night. It's good to see you popping back in here. Seems like a lot of people were having work stuff come up around this time right now. I don't know if there's a lot of projects in crunch right now or something. But yeah, I posted these two ones on my Instagram and Twitter and stuff just from the explorations we were doing yesterday. I might try like, I was running just adding the time to the noise offset, that fourth dimension, and getting some interesting motion and stuff like that. So I might add that animation procedural. I don't know, some of it looks a little like glitchy, but it was kind of cool. The 1K vellum. I don't know. I thought it was kind of cool, but my transition is kind of borked. I was doing like too much stuff at the same time or something on it. But yeah, I'm trying out some different vellum stuff. I think Alex was talking about doing wires or something like that for a future stream. I've been trying to screaming for another tutorial. I'm like falling behind right now. There's a bunch of different stuff. I've been trying to figure out just more vellum stuff in general. Steve GH, how's it going? I was trying like some font. Whoa. This is a pretty cool one. I've been playing around with the different attributes and stuff because I've been trying to add them to my Vex cheat sheet. So just to get a handle on the different things, that's why I was playing around with this different vellum stuff or whatever. Yeah, we need to get the grains wrapped up, vellum grains wrapped up, and then move on to some more vellum attributes, animations, and stuff like that. Yeah, so this is what Billy had posted in the Discord. So just gonna look into it. Maybe I don't know where this animation is. It's like halfway into the thing. Dr. Robotvinik, good to see you again. There's a area where he's going around this like figure 8 or infinity. There it is. It looked really cool. So there's that one. There's one of these ones from the V-Ray marketing materials that I was looking at for reference. Yeah, the stream just started, so I'm just kind of introing. This is what I'm going to be looking into today. Is this kind of different references of this car burnout, tire smoke, or whatever. This one was pretty interesting. There was like he like blew out his tire in the middle of this or something. But yeah, it's just gonna be, I don't know how far we're gonna get today. You put these in the thing if anyone's interested in examining them further. So with Arnold, the Arnold renderer or whatever, they have these different learning scenes. You get some geometry and models and stuff. So I grabbed the car studio lighting because it came with a nice like Lamborghini model or something like that. So we'll just pull that in and get started. So if you're looking for these geometry or Arnold scenes, you just grab stuff from there. So using Alembic, when you export stuff, it usually will export the entire like scene hierarchy. If you press the 9 button under the selection mode, then you can see under the gear you have Alembic paths. So if you click that, then you see like the entire hierarchy. So if you're familiar with Maya, this is like the outliner. Every 3D software kind of has this kind of thing. With Houdini, if you go to the network view and press Shift W, it's the same concept of this hierarchical arrangement of objects and parenting, inheritance, or whatever. But this is useful because I could select stuff, and then if I press delete to do a blast, it will delete it based off of the path attribute instead of the point number or the primitive number. So this way, if you're working with an animator that's going to be updating things over time, he doesn't have to worry about keeping the point number or the order of stuff the same. He could add extra geometry to things, and as long as like the floor stayed within this group or this shape node, your Alembic kind of script or stuff will keep working. So it's a bit of a trick working with Alembics. It's just going into the selection mode, then the 9 key. You could also select stuff based off of this, and then you just have a nice kind of colored visualization. So we'll just start by getting rid of that floor plane. It's just a lighting kind of thing. Might grab the wheels. So it's pretty nice the way that this hierarchy is set up. All the wheels are grouped under a thing. So if I just press tab and split, then we have the tires separated out. So you can see even these longer strings or expressions, it can just keep adding like really long selection sets or whatever. So that just happens if you have your mouse over the viewport when you're blasting or deleting, because Houdini's context sensitive. You can't move the mouse over here and then put the node down. It has to stay over the viewport. And then I might just do invert selection to keep like the body in the main stream. And then sometimes I'll just do like what I'm isolating. Maybe we'll just do wheels. And then you could do a null. Whoop. You want to start separating some of this stuff. So this will just be like main, body, and wheels. This guy's got some fat tires in the back. What I might do with these, I might just continue to split these out. We'll do the front and the back. So I don't know if we have any Lamborghini owners in the chat. We have any oil princes? Do you guys know if this is, are they usually rear wheel drive or all wheel drive? The front tires split out and the rear tires. What I'll do with these front ones, I think we just need to, the newer ones are all-wheel drive. It looked like some of the references that I grabbed, like this one that was in like the hangar, this seemed like all-wheel drive. Like all the tires were kicking out smoke. But I've seen other references where it was just rear wheel. I guess I don't know, like typically performance cars are rear Hot Wheels. Seems like performance, like racing. I don't know. But yeah, this is a really cool shot, cinematography for how that happened. But yeah, what I'm gonna do here is I'm just gonna straighten these tires out so we have like a kind of default rig or whatever. Get everything straightened out. So we'll do another split. Nothing happened. I didn't grab it. Maybe this template. Sometimes this viewport selecting things is a little bit buggy. So we do another split. I'm just gonna copy these nulls. And now we'll just do this from we love the Insta post. Thank you, Gamma Bassoon. Yeah, I might do one more from that from that series. I was saying earlier I might try an animation or something like that. That was like evolving the fourth dimension of that noise, or just adding the scene time to it and getting some like interesting evolution. I might try a different thing as well with like, I don't know, a few of these pedestals lined up, doing like a rack focus, or I don't know, something just to vary the composition or the framing or something like that. But yeah, I appreciate everyone getting the hearts going on Instagram. So we'll just do the transform. Sometimes people have scripts or stuff like that to change this origin. Sometimes I'll just do move centroid to origin, and then that will snap the position and move everything to the origin. You could just do revert to defaults, but clicking this will still do this kind of macro to get the centroid. You could also do expressions in here to get the centroid or stuff like that. So I'll just go into the top viewport. We could do maybe wireframe. I don't need to be super precise with this. Yeah, I mean, it depends. Like, everyone has their own way of doing things. And some people make a preset. Just because I'm doing these streams or recording tutorials, I tend to try to work more of like the stock tools. You just do move, right click, revert, and then you have your thing lined up. So let's, ooh, what happened here? I think this might be the normals, maybe? There's just weird viewport display things that sometimes still happen with the Alembic stuff. So we're not doing CAD work or like engineering stuff. We don't need to make these too precise. I just want them to be generally pretty straight. And then we're missing the back tires, so we'll just do merge left and right front tires. If we want to be super clear about the naming, we could just do this from the point of view of the driver. So this one will be right front tire, and this one will be left front. This is nice. I don't know if you just are going back to add animation or stuff to them, it makes it easier to find stuff. And then we'll grab the rear tires. So let's do front, rear. Maybe at the bottom here, we'll just do like out wheels. And then if we want to add animation to them, I'm just going to work at the origin for right now. We might do more advanced stuff later on with having him drive along a path or something like that. But I'm just doing more kind of R&D or initial like effect development for right now. So with these rear wheel tires, you can do the same thing and revert back to the origin. And then we just rotate in X. This is like he's going in reverse. And then this way he's going forward, I think, right? Am I going the wrong way? I think that's right. So you could do negative $FF. He's going kind of slow. We can multiply this by maybe 25. So you might have to be a little careful with this not being perfectly center. But for right now, I think it's okay. And we can do the same thing for the front tires. So I don't know, sometimes that's just a viewport trick or an error. I might just copy this parameter and paste the references. So we'll just start with all the tires going. We got some wobbliness happening right now, but we'll just keep going. We could fix it or really refine things if we have to later on. So right now we have these as packed Olympics. So you could see we just have like 20 points or 20 primitives. Even though if you look at this model, if you look at the wireframe, like there's definitely more than 20 faces or 20 points. So the packed Olympics is kind of like packed primitives. It just allows you to edit things a little bit more easily. Like basically with this 9 key, each shape node or each entry in the hierarchy is one packed Olympic. So this is treated as 1 point, 1 primitive, 1 piece of data. And if you want to access them further, you can just use the unpack node. So we look here, we go from 20 to a bunch more points. The primitives themselves are still treated as polygon soups, which is kind of nice. If you want the full kind of heavy or dense geometry, you can just do a convert at the end, and then you have the full kind of data that you can modify if you want to. Just press the 9, go back here. You would see this, some of these faces got flipped around. I think that happens sometimes when people model it and they do a mirror operation. They just didn't pay attention to their normals and they didn't flip their faces or whatever the right way. You would fix them if it turns into a problem, but we can just ignore it for right now. And then we have a position, point position, a normal, and UV or texture coordinate. One thing I like to do is transfer this path attribute. So it preserves the place in the hierarchy. We look at the spreadsheet. You can see adding this path, it keeps this hierarchy place. Deleting it will just hide it or whatever. But it's a good idea to keep it. This way, if I'm exporting this again as an Alembic, I could build the hierarchy from this path attribute, and then when they open it back in Maya or whatever software, they would still see that hierarchy and still see everything named nicely. If you don't do that, then everything just gets flattened down into this like object that you're working out of. So just keep this path around. It's better to have it than not. I'm just gonna get rid of the other stuff, so we're back to only wheels. I'm not gonna convert right away. And if I go back to the 9 button, I can still select things based off of that path attribute, which is nice. I'm gonna grab the outsides of these and just do another split operation. So we just have the rubber areas of the tires. Professional Houdini wizardry. Thank you, Kabukaku. Kabu Kabu. Is that how you say it? Kabu Kabu? So now we have the rubber bits of the tires. It's a weird topology that they have. It's like weird kind of subdivision, octree style or something like that. But if you're not too interested in the topology and stuff. Just do scatter and extradite. How's it going? So it looks like this, without converting from the polysoup, these guys are having some trouble getting scattered properly. But because we've deleted things based off of this path attribute, it's just more procedural. Like I can change the primitive count, change the point order and stuff, and my selection set will still remain the same. So it's a big help. Just keep you more flexible working that way. And then we're scattering, but if I want to do something like a trail on these scattered points, to compute the velocity, it looks like it's working. Sometimes when you're working with like really fast moving geometry, you want to make sure you have the subframe information. Stasha, how's it going? Yeah, it's a cool topic. Hopefully not sure how far I'll get just today, but hopefully we'll make something cool from it. So what I did there, you just click this global animation options, Alt-Shift-G. I turned off integer frame values and did a step of 0.1. So the reason for doing this is then you can play back and get the decimal frame values. If you're ever looking at animation from other software packages or stuff, sometimes, like if I do a time shift somewhere here, then you can see I don't have subframe information, I just have integer frame rotations. So if you're doing a tire spinning effect or stuff like that, the motion blur, all this stuff is like super important to be accurate. So we want to make sure we have subframe information. You're watching the YouTube? Thanks for making the journey over to the Twitch world. So like if I'm just doing this time shift to force integer frames, you can sometimes recover subframe and information using this time blend. But you can see here we have some artifacts on some frames and stuff like that. It's also possible sometimes, like if your tires are rotating way too fast, like you're doing maybe like half a rotation every frame, then you get this weird crisscrossing in your motion blur and stuff like that happening. So sometimes you might have to ask if this animation was done in Maya or another 3D package. On their Alembic exporter, they have this motion blur setting where basically you can store more than one sample of animation information per frame. So if you have really fast moving tires, sometimes they've had to export the tires separately from the rest of the vehicle, just with higher animation sampling, with helicopter blades or just any effect that requires like really fast moving stuff. Sometimes you need to do that, but just inspecting things to make sure it's looking right. And then with this points right here, it's a bit sometimes bad form to be like scattering points on geometry that's transforming or animating. So what I usually do is I'll record the primitive number in primitive UV and then use a time shift. And this one I'll just do it as a frame hold. So just lock the frame at this first frame or the current frame. You can see this still has a time dependency icon, where it's saying every frame it's going to recook or reevaluate things. It looks like that went away after it after it cooked again. Sometimes this animation here, this gets like a frame dependency. Sometimes you have to do a frame hold on your base Alembic. But it looks like when it reevaluated things that got fixed. So now we're just scattering things on a static frame. And then if we want to reapply the animation, you can just do this attribute interpolate. So you just connect it like this, and it's already set up to use this source prim and source prim UV attributes. So when I scattered the points, it records the primitive number and the location on the primitive that it's placing the point, and then using that attribute interpolate, it can update the information. So now we have accurate subframe animation. You could do maybe the central difference. It looks like it's more accurate maybe than Z8 editing. Thank you. Yeah, it's a bit in the weeds right now. This central difference, you just want the most accurate information possible. So it's a bit in the weeds, but we're just making sure before we start, we want to make sure our information or our source motion and velocity is precise or accurate. And then the last thing we could do, there's different ways to do a lot of this stuff. I'm just gonna make a copy over here and do delete non-selected. And then this is just gonna be ground. So I'm just gonna grab that same ground plane information. We want to unpack it. And then what I can do with these points using the ray, not like this. This is kind of like a LiDAR scanner or something like that. What I want to do is just do minimum distance, and I don't want to transform the points. I just want to store the intersection distance. So this will just record how far these are from the reference geometry, or the distance to whatever geometry we have in that next input. So if these were going over a bumpy rocky hill, or he's lifted off a ramp for a little bit, we would always know whether which parts of this tires are scraping or not. We can visualize this instead of looking at the spreadsheet. If we just do a ramp from attribute and dist. So we can see based off of the height or distance in meters between 0 and 1 right now, where we could change this setting as well. We might want to flip this around. Now this is kind of our visualization of maybe like friction or areas that are colliding or rubbing against the ground, and this is going to be basically our emission, the flow zone. This is the zone of the flow source, or the fluid source. Let's go back to perspective viewport. Somehow I jammed a bunch of hotkeys there. And then there's different, I'm just gonna keep trying to name this stuff. So we have the rims and the tire rubber being split out there. Yeah. So I don't know if I want to keep doing this visualization. For right now, what I'm gonna do is just blast or delete based off of the distance, and if it's less than 0.1, maybe we want more points. All right. So this depends on your preference. I usually like to do another particle simulation before moving into DOPS or moving into a smoke simulation. So with this one, we can just say from the source points, kind of spray things outwards. And I'm gonna go back to my integer frames. So we just get this really kind of boring or bad thing. Basically we have an anti-gravity thing and we're just shooting things on the velocity and nothing causes them to change. So we want to ground. Now we've at least fixed one of those issues. The next thing we probably want is like a pop drag. So now we have a bit more deacceleration over time or something like that. Like generally we just want the fast motion to be right where this stuff is colliding, and then over time very quickly it just slows down because of like wind or air drag or stuff like that. You might want a bit of gravity, kind of depends. This kind of stuff that we're representing, it's not really a physical element, we're just kind of creating a guide force or something like that. We'll just put that in. And then on these source particles, I'm just going to change the life expectancy. So that might even be a bit too long. So I'm just interested in the first few seconds of this, just to get some basic kind of shape or motion. Yeah, I'm gonna be adding a bit of turbulence in a little bit. One of the things you can start with is just doing add to inherited velocity, a bit of variance. This is kind of just like making a cone or giving these some random directions. So with no variance, we'll just get perfectly straight emission. The more variance we have is kind of just like a random spray. So this visually is depending like just how much expansion or how much kind of width you want of the smoke coming out. Yeah, and then with noise, there's a lot of different ways or things we could do with noise. One thing we could do is add noise to our emission so that we're not sourcing from this. Like these wheels could have a texture applied to them such that certain patches are emitting more smoke than others. Let me just keep this stuff named a bit more clearly. The other way to add noise, or another aspect we could add noise to, is just the direction, like the turbulence. So with the pop force, you have the constant force we use right here to add gravity. We also have this generic noise. It's like a curl noise. We'll turn our velocity stuff back on. It's kind of hard to see, or maybe we need a lot more because we're starting with like a pretty fast force, like initial velocity. But this curl noise is kind of like a wind or turbulence or something like that. So we might want to decrease the swirl size. Seems the tire smoke from the front wheels should be less than from the rear. What do you think about that? It depends on the reference and stuff like that. So we'll be able to tweak this setup pretty easily. Yeah, I was talking about this kind of stuff earlier with certain certain cars might just be a rear wheel drive only. So we might not even want to simulate the front. But I think like certain references, it was just from the back. This one was the main one that I was kind of just gonna start doing a setup for because it's not moving. So this one, they seemed to come from all directions and like fill everything up. But all of this stuff is pretty easy to be changed and adjusted. So already, just because these are a bit wider, the difference of pop force and pop wind. So pop force has a bit of a run up, like you're injecting this force into things. How he stays so still with all the wheels spinning. I don't know, maybe he put vegetable oil on the wheels or something. Pop wind is treated like this force is already existing in your scene. So everything is immediately inheriting this kind of motion or this directionality and stuff. The pop force is... What the hell is going on here? The pop force just has some run-up time, like it keeps adding every frame until it catches up to like the terminal velocity or whatever. Does that kind of make sense? The pop wind is like this force is occurring everywhere, so the particles will align with it and match to it. And pop force is you're injecting or you're adding forces to certain parts of your particles or whatever. So it just depends, like that's kind of, I guess, why they named them differently, but it's kind of it's not the most clear, but that's what they mean with it. So I'm doing a pop force here, basically so that at the start, our spray is pretty forceful in this direction, and then over time, is it the same logic for treat as wind? I believe so. Like if you see on advect, pop advect by volumes, update force is basically adding your velocity volume using this kind of method. And if you uncheck treat as wind, I'm sorry, I got ahead of myself. So without treat as wind, it's doing a pop force application of things, and treat as wind is doing this kind of method of things. You could go inside of these if you're interested in fully inspecting them, but the main difference is this add wind force that does the target V kind of stuff, and then this one is just using force. It's instead of target V is force. So it's different attributes that the pop solver knows how to treat those things differently. So I'm doing pop force because I want over time these stuff to like gradually spread out or fan out more, instead of like pop wind would be he's driving through a very windy environment or chaotic environment or something like that, and all of this smoke immediately is like getting affected by the wind. So I might go up to the birth and do a higher birth rate just to try to visualize a bit more of this stuff. I was using Houdini for, I don't know, it's been centuries. I think since I don't know, maybe like 2014 or something like that, like 6 or 7, 8 years. I don't know. Since Houdini, around Houdini 12, it was pretty much when I started. So I'm just gonna hit this magenta flag to make the ground plane hidden. It will still affect things, but just visually, we make it invisible. And then I'm gonna add some sub-steps. I might do the sub-steps up here at this global level. So this should give us a little bit more accuracy in terms of some of the collisions and stuff like that. Before, you could see there was like a frame or two where things dipped down below the ground plane. And then under object merge, we'll just do pop object. So this way we'll just be pulling in the particles and not the ground plane. You might want to turn on this little timer thing at the bottom. So this will just give you like the real-time playback instead of, otherwise it will just play back everything as fast as it can. So this is just a bit better to evaluate the speed of things. But I think this is going to be good to get started with. So if we want to the cinematic was good, but the gameplay is bad for that Halo cinematic. I think it's just because that's different departments and different teams that do game cinematics, and actual gameplay is different, art directors and all that stuff. Geronimo, how's it going? So we'll do a you're watching the YouTube? Which one were you watching? So I'm going to set the color attribute from this N age. The N age is a special attribute that doesn't really exist on the geometry, but it's derived from the age and life attributes. So it's the normalized age over life. It will just start at 0 when the particle is born and end at 1 when it dies. You wanted to add some fog to your render and looked up the stream VOD on it? That Redshift one? Are you using Redshift? It's because I guess it's pretty different if you're using Mantra. Oh, you're using RenderMan. But yeah, that's a good one for just generating kind of procedural fog or stuff like that. So what I want to do with this N age is control the key scale. And then if I press the D, we could go to disks. And it's already a bit too big. All these things are huge because it's like 1 meter. So I can just multiply this by a smaller number. I think sometimes this normalized age is outside of 0 and 1, maybe? Let me just clamp it. So maybe sometimes it's just gets like division by 0 or something that makes it really big. And I think what I want to do is maybe do a ramp. So I'm just going to call this ramp age, and then instead of starting at 0, we want to start big and get smaller over time. So kind of like fading out. We might be able to go a little bigger. We can always adjust that stuff as well later on. So we have divided by 0 makes it really big. Houdini learning. Yeah, I don't know. Anytime a computer isn't doing what you want it to, just ask the programmers, is it dividing by 0? I think that's like basically things will go wrong if you are dividing by 0 or small numbers. So we'll just do an attribute rename and kind of cleanse our attributes, get things a little bit under control. Because right now we have a lot of attributes that the pop solver adds, like pp previous, p scale, source prim, source point num, target v. We don't need all that stuff. There's no animation right now. I just added some basic animation just using this transform. We got some wobbliness going on or whatever. But this is just initial scene setup and kind of development of our solvers and stuff. Probably later on we'll be expanding, continuing on and building things out more, but just for right now I'm starting simple to develop the forces and stuff like that. So we'll get rid of these. Basically all of this extra information adds to your geometry size, and it just is good to kind of purge it and keep it a bit more manageable. So with these attributes I want to keep, we want the ID that just allows you to recalculate velocity or keep track of these particles, because the point count is changing, but the ID will be consistent for these particles across time. We want the velocity and we want the p scale. So I think that's all we need for right now. I just did that in the wrong box. So instead of deleting them, we want to keep only those attributes. And the position or p, you have to keep it. Basically, you can't really get rid of it unless you like just set it to 0. So we have our position, ID, p scale, and velocity. And we might want to cache things, the disk. And it's probably a good time to save, just in case something goes wrong. So we'll go into the stream, the vault, file this one away, due on July 25th. So I usually just work out of a scenes directory for my Houdini files. This one will just be like vehicle setup. And then in these file caches, I usually do like a relative path. So in my working directory, I have the scenes, and then you go up a level, we have geometry. The $OS is just this operator string, or the name of the node. So this will be source particle sim. And sometimes I'll do the version number on that. This way it will just make a folder that will be sequential versions or whatever if you want to switch between them. We should be good. I don't know if I really need 250 frames, but we'll keep them. Looks like that saved to disk in the background still wasn't working. So we'll dump these out to disk. It's inspiring to see how fast you're able to translate in Alembic, isolate what you needed while cleaning the mesh to Houdini. Started to work on the actual effect you have in mind. Yeah, I think it's just from repetition of doing it so many times. But yeah, I think working with Alembics is getting easier to kind of manage files from other software and stuff. Like in the past, before Alembic and the name attribute and stuff, you used to have to like manually select faces, and it would just take a lot longer to redefine things. But especially with USD, once that gets more widely adopted, like you should be able to bring in stuff with the shaders and material properties and have all that stuff translated and come across a little more quickly as well. I don't know if I'll be able to find it. There was a tire effect I did recently. Somewhat recently, within the last year or so. I don't know if I can find it. Gymkhana videos? Are those the ones where he's on the cliff? Where he was going like on the coast? That was the one? Are they all the Gymkhana? I don't think I can find the other one. Ah, Gymkhana 7. That's this modified Mustang he has? Where they do it? Whoa. Get that. Get that powder gun. He does different cars each time. There was one that I saw a thumbnail of where he was going like along the edge of the highway, like on the cliff or something. That looks pretty cool. Seems like he's always in the Bay Area somewhere. Or like somewhere on the West Coast. But yeah, I've watched a few of these. They're all pretty, he's super talented. So I'll just cancel that simulation. We don't really need 10 seconds of source particles or whatever. Yeah. So we have this stuff spinning, generating stuff. And I think we're good to do our next DOP network. We're just gonna do the standard, my patented pyro particle method. I should make a shelf tool or something like that to speed this stuff up a little bit. But basically I just make a smoke object. I do these expressions to get the bounding box dimensions of that box, or whatever geometry is plugged into the last input of the parent node. So this ... is basically the node that I'm inside of. Yeah, I could set them as default. I tend, I don't know, for whatever reason, like doing streaming and tutorials, I tend not to do it just because it might throw people off if they're watching things for the first time and I'm just like doing a speed run. But at facilities and when I'm working at places, I'll usually just do this on the right click and do either save preset or save as permanent defaults. But it could be nice to make like a script or a shelf tool that you just click and it will update them and assign the expressions or whatever. And then we'll do the X size. We can just keep adding each of the X, Y, and Z components. So now we'll just pin the view inside of here, but if I change these box dimensions, it will update. So we've linked that up. Then I also just, thoughtful John. Yeah, so we'll add a centroid. You can just do this. So we don't need the size, we just want the individual components. And again, if we want to double check, I can just move my center around and it moves around. So let's take a look at the size of the car. Probably should have also done this earlier, but it turned out okay. Sometimes you need to make sure your car isn't a lot bigger than these world units. You can work at other scales, but it's doing effects or anything physics based, it's good to start out in kind of reality or something close to it. So this guy looks like he could drive that car, or he might be able to cram into it. Been taking too many steroids. Needs to slim down a little bit. So we'll look at these particles and look at the bounding box. He's swole. With the bounding box, I'm just gonna do this match size node. And instead of changing X or Z, I'm just gonna do the min of Y. That just means to move it above the ground plane. So something like that should be good to get started. Just want to give ourselves more space than we need. And then we can do a smoke object, or sorry, smoke solver. This one I'm just going to do it to solve on creation, and then I do a multiple solver. With the SOP. Started off with the SOP solver. And then this one, I can just grab the op input path expression and use it here, but instead of the last input, I just want the primary input. I think we need the backticks for that to have it evaluate as a string. These ones we don't need the backticks because these are returning a float value, but for the operator path we need it to be a string. And then we have our particles. We can see them. They're in the geometry section of our smoke object. Then we can do particle to field. And we'll just put these into density. We don't have a density attribute, so if we turn that off, it will just use, we'll turn off extrapolated, and then it will just use treat it. Based off the particle scale, it will just basically treat it like it has a value of 1. We want to add it. And if I look at my resolution of the sim, we're pretty low resolution. So we'll go a bit lower. But this is pretty good just to get started testing things out. If you don't want to see the particles anymore, you can just hide them for now. This adds density every time this cooks. So whatever your substeps here are, or globally, but every frame of the simulation, it adds them. So if I play it, we can see things getting added. We have no motion. So we're just putting smoke in, we're just adding density, and the density doesn't affect anything else. It doesn't change the buoyancy because it doesn't have any temperature. So basically all we're doing is just adding to density, but there's no motion or anything moving around. So we can just make a copy of my particle to field node. And with this one, instead of going into density, we can go into velocity. And this one we do want to use the attribute. So we'll do V. And again, we just want to add things. So now you can start to see we have a bit of pressure buildup. We have the force from our particle simulation. And using the velocity attribute, we're injecting or adding velocity to our smoke simulation. Now I usually go up to my object level pretty quick or soon, and I'll turn off the cache for the smoke simulation. Under the object merge, I'm just going to bring in the density, and then using this pyro post process. This is the new way. So with this one, we can convert to VDB and do all of our operations with just one node. Before I was doing like 5 nodes to do all these steps. So the reason to work up here is it should be a bit quicker. Right now I'm doing a CPU simulation, but if I switch to OpenCL, you can see now we're getting faster playback, closer to real time, or just quicker to visualize everything. So doing those steps of turning off the DOP geometry cache, this will just let you work the quickest this way. And if we want to change the thickness of the density, we could change the visualization at the very end, or if you just do like source pre-molt, this is like scaling the source of everything. And then I'll usually add light just to visualize the density. Like getting some shadows in there helps you see what's going on. So I'll usually just kind of shoot it off super far, and then under attenuation just turn that off. Because I'm not really using this light for like rendering purposes. This is just strictly for visualization. The multiplies the value before it cooks. So source pre-molt means multiply the source attribute or the source value before I'm adding it to the existing density. Destination pre-molt would like be pretty wacky, because then this existing density gets increased every frame. I don't know, there might be a reason why you'd want to use it, but source pre-molt is saying pre just means before you do this add operation. So you could do it that way. So if we see we have like this fuzzy stuff happening, and then that's like a sub-step kind of issue. So if we again turn off this integer frame stuff, because we saved this out to disk using $f, we just have integer values. So we want to do a time blend just to recreate or re-interpolate. You see some artifacts at the start, but that should be okay for right now. And at the end, with unmatched points set to freeze, you can see the particles are dying, like, and before they die, they just stop. So instead of doing that, we could say delete, and then we don't want like stopped particles still affecting our simulation. Depends. Other situations for rendering or reasons like that, you might want it differently, but for smoke source, this is a good way to use it. And then this is a little trick, but for fast moving simulations for sources, you can do a gas substep microsolver and put it underneath here. So if I do 4 substeps, this will basically do like a motion blur, or like 4 substeps just for my sourcing, just for adding the velocities. But my pressure solver, the more expensive, heavier areas of the DOP network, will still just be running with the 1 substep. So basically everything above this you could have this 4, or you could even go up to 12, and get rid of that fuzziness, or have smooth velocities and smooth interpolation and stuff like that happening. The only thing you need to be a bit careful about is when you do that, then you're multiplying kind of these numbers by 12 or whatever. So I usually keep these 2 values the same, and then if I just link it up with an expression, this way you can change the substeps without changing the visual results of like density becoming thicker or velocity becoming too strong. I think I want to get rid of this integer stuff. So we're back, kind of playing back at real time or whatever. So I might want more velocity. I can just increase that number. What was there? I thought that there was some I might try this remap node. I'm just going to use this with p scale. I think I can do it. So I'm basically here, I'm just doing multiply the p scale by 4. This is just a quick way to change the size or display and stuff of attributes. So it looks like this, my velocity is too strong now. If you make the p scale bigger, you generally want to compensate and remove some velocity. You tried the Pyro post process. The only thing you didn't like is the redshift shader isn't applied when the display flag is on it. Yeah, so what you can do in that sense, you can work, like if you do this null and then you hold down the T button, or even like this, then this geometry will get sent to redshift, and this will just get sent to the Houdini viewport. But what happens with this is they assign a material here at the geometry level. So this shot material path will override what redshift is doing, even if you have a material set up here. So you just can link, kind of do this trick or whatever to send this to redshift and send this to the viewport. So I reduced the velocity now that I increased the scale of the particles, just to keep things from getting like too much out of control. This stuff is going a bit too slow. I'm just going to go down with these substeps for a second. So hopefully you could see, because I added these expressions to kind of normalize stuff based off of that, we can change our substeps and still get visually or physically kind of this similar kind of results. We might even want to go all the way up and just do a visualization here for a sense of scale and stuff like that. So we don't have collisions or anything like that turned on right now, but we're still going to dial in forces and stuff like that. So it looks like these things might be shooting a bit too far, and it's just too thick. I'm going to scale some of that stuff down. That seems a little bit more to scale, or with timing and stuff like that, it seems to work a little bit better. I'm just going to add turbulence to the velocity now. We'll link up the OpenCL stuff. So this turbulence should add a little bit more detail into these pressure fronts. Or basically, instead of one big mushroom or blob, now we have like that kind of stuff subdivided into 3 or 4 different plumes or whatever. You might want to go even smaller, so that swirl size is controlling the scale of that extra detail and stuff that we're adding. So this, you would just want to be looking at your references and things like that. That stuff's a little bit different with the way that they have collisions going, but some of these you can see it is like this kind of stuff. The little extra billows is kind of what I'm looking at there for this swirl size. And I usually switch this advection method to BF ECC and trace RK3. So those are just a little bit more precise. Using OpenCL, you don't really have to worry about it slowing things down. If you're doing a CPU simulation, that can sometimes slow things up a bit. So I might go a bit higher with this turbulence. It kind of has to do with like your initial velocity. If you're shooting stuff into a simulation at a high speed, then you just need more turbulence to break that up or combat things. If this was just like a candle getting blown out or something, you don't have a big initial velocity, so you wouldn't need a lot of turbulence to modulate or to change that kind of stuff. I might even go one step higher. And I'm also going to go to the viewport and turn off my texture resolution limit. So this way it won't clamp my the resolution of my smoke. So it's pretty cool. It's just starting to figure out settings and stuff like that of how big we want the smoke stuff to be. What we can do now is just add the vehicle in as a static object so that it will affect some of the airflow. So before I was visualizing this just to get a sense of scale and change the swirl size and stuff, but now we'll physically add it in because it will change the way that the velocity flows, and it will change just our overall result of the simulation. In the flow zone, So we have the main body. Again, this is packed alembics, so we could just do convert to go to the actual polygons, scatter. I'm gonna go back to points. The reason I do scatter, I want to convert this into a volume, like a VDB, but sometimes if you do just VDB from polygons, it will have trouble at certain resolutions and stuff, like determining the insides and outsides of stuff. Like this is kind of like you're making a toy or something, and you just took this out of the box and it got the wrong stuff. So what happens is, like, this geometry that's not watertight, or it doesn't really have an inside and an outside, it's just a bunch of open surfaces. When you start to convert things at a higher resolution, it starts to detect these like gaps in the surface, and then it's like brain gets cooked because it doesn't know. It's like trying to figure out inside and outside, and then that keeps flipping around as it's like going inside and saying like, where's this surface or whatever. So if you just do a scatter, you can go like quite dense with the overall amount of points. It takes a minute to cook. We're doing some relaxed iterations and stuff like that. But now we have a pretty thick blanket. And if I do VDB from particles, this way the VDB from particles doesn't worry about trying to find inside and outside. I was just trying to think. I didn't want to, like, sometimes you can crash. If you leave this p-scale radius at 1, it will try to make your VDB really big and it will crash things. But now this is not worried about whether things are inside or outside. But the only issue is that you have this like shell, or you have two sides to your surface. So if you just do this VDB from polygons at the end, then it's able to detect inside and outside, and it can enclose everything. You can inspect some of this stuff if you just do the slice. So it's able to fill in those holes. It looks like because of this gap down here, it might have some issues filling that stuff in. Sometimes you can just make this p-scale thicker. It might be there's like vents or stuff like that somewhere. VDB from particles and then VDB from polygons. It's a bit of a hack. So this warning signal here is saying geometry has been converted to quads and triangles. The VDB from polygons is smart enough to, it's basically adding a step in behind the scenes or whatever. And it's doing a VDB convert. So it's taking this VDB, going to polygons, and then doing this kind of behind the scenes. I don't usually make these nodes because it's less nodes to create or whatever. But that's basically what happens. So you scatter a bunch of points, then you do a VDB from particles, convert VDB. When you do that step, you'll get like a lot of double-sided surfaces. Like a lot of this stuff will have an extra thing inside of it. But then when you do it again to polygons, it will clear out the insides. So that's what I was kind of trying to show with this. slice. But it looks like we still have a lot of air kind of inside of the cabin and stuff or whatever, but I think we don't need to worry about it for right now. This should be good enough to block some of the air. There's some other things we could do, and sometimes if you're working like at a actual studio with modelers and stuff, you can have them, you can tell them you need like watertight geometry that's like collision geometry. But for right now, this should be okay. So we'll just say this is out main body SDF. So SDF is just saying it's a surface volume VDB. This distance VDB is what people call the SDF. So S stands for signed. So that just means it knows the inside and the outside. D is distance, and F is field. Fields is just like a volume. It's the same thing or whatever. So now I usually just add these collisions using the static object, and under collisions we can do volume sample, and then you can supply that using the proxy volume. Whoop. Got the wrong node. The submerge field. So this way we should be good to go. So I think all the other stuff we can leave blank. I'm just gonna do a flip book. We'll just check our results and see what we get. I'll go get some water. I'll be right back. Oh no, my lights fucked up. I forgot to turn that off. So that's the reason why I added the light in my scene or whatever. If you just have the headlight on, you're basically just looking at an alpha channel. You don't see a lot of the shape in the smoke, and it's harder to evaluate stuff. So we might want to do something with this turbulence so that it doesn't get added after a certain point. That's the main issue that I'm seeing right now. So I'm gonna press escape. I'm actually just gonna go in and disable this turbulence for a second and just run our simulation for a few frames. So this way, what I'm gonna do is just try to look at everything and see, like, you could tell that our collision's working because it's erasing that area. This is what I meant though about the inside. We might want to clear that out, but for right now I think it's okay. I'm gonna make the P scale a little bit smaller again, and one thing we can do instead of adding all of our turbulence using gas turbulence, if we go up one level here and maybe just do an attribute VOP, So we already have these particles that we were adding stuff into the simulation with. But if I just do a curl noise and we do, I usually do this vector to the vector 4. Then I can add this curl noise directly to the velocity. And by doing this, it's very similar to the gas turbulence. But instead of gas turbulence adding things to existing density, we're already just starting out and just injecting turbulence in our source. So we're able to control things a little bit earlier, and it should be less chaotic. Like the turbulence won't be added once smoke leaves this area, essentially. It's a bit cheaper to run this operation too, because you're only adding turbulence to points, which is quicker for the computer to run than adding turbulence over voxels or like a big smoke simulation. So I'm just jacking up this value quite high to try to see the overall frequency. So this frequency is kind of the same idea as like swirl scale. And then if I increase, or if I connect this to time, then you can see this is like the pulse length, or changing the, evolving the noise over time. So we'll just say add turbulence to V. I might go a little bit higher with the resolution of this simulation. All right. Let's take another look. So I did decrease the particle scale. I made it like half as big, and that might be that has the effect of decreasing the velocity overall when we did that. This stuff is looking nice. It's like it's so clean. So I want to go back in here. Velocity, probably want to go back maybe closer to 1. And I think with this turbulence, you can just add a bit of it. So I'm doing like 10% of the original turbulence, and I doubled the velocity. So the static object that I added will source collision. For right now, because I don't have animation of the car swinging around and drifting or whatever, I don't need to worry about that area of things. And then with these source velocity particles, that stuff I'm kind of treating like it's the collision velocity, so I'm not bringing in any collision velocity. The static object node will add Is it back? Are we live? It's working. All right. We got it. So I don't know what happened, if it was my internet locally or if it was a Twitch issue like that. I don't know. But yeah, so I just saved out those particles with the upward, more of the upward trajectory. I think that's around where it died when I was just running this file cache. So we should be back in action. So I'll just run another flipbook. And now instead of too much of these, like the booster or the this is when you hit the NOS. If the car was animated, it depends. So I might want to change the way that I'm doing this collision stuff. Oh my God, Brando, thank you for gifting all the subs. My goodness. Could I get a W in the chat? Paying the poly doctor. Let's fucking go. So I think I need to sort out this collision stuff. The true hero. Let me just cancel that. So with collision vel, you can do a few different things. With this car, if you're able to do the animation at object level, then you can use this object transform. I usually try to work that way. Because then you're just bringing in the transformation information and it will create collision velocity based off of that. If it is moving or deforming at the SOP level, then you might want to bring in the collision vel. Does that kind of clear things up? So I think if I look, I'll go into the pyro simulation and I can turn on collision, and you could see I have the collision representation with the collision volume inside of my simulation. So this will source collision because of the way that I've set it up. And if you have motion happening here, it will also source collision velocity. You could do a test with like a sphere. If you move it around at object level and then use object transform, it will actually add animation. Like if you're doing a fan motion or something like that, it will swirl the velocities around. We'll get rid of that. So what I'm gonna do up here is I'm just gonna make these VDB stuff a bit fatter. So the bigger we make it, the more we should fix. Eventually we should be able to fill in the interior. I don't know if there's like big, there it goes. There's like really big air vents or something like that. So now we have a fat vehicle. If we want to, we can do reshape SDF and do erode, just to get like a little bit thinner. But we still have the interior stuff built in this time. So I might leave it still pretty thick. And that should be okay. And then I might go in here and reduce this source velocity. So I'm gonna do 25% of what we were doing previously. I'm back. Yeah, I don't know, were other people on Twitch going down, or it was just me? Uh-oh. Oh man. So I just tried to bypass that to fix it, but that triggered my collision velocity stuff to all recook. It's gonna take a second to figure that stuff out. Alright, it works. There's like a bonus. The stream went down. When it came back up, you had a sub gifted to you. Alright, so we should be good. Do it again. So one thing we could do, like, oh shit, you're right. One thing I'm thinking I'm also gonna do is just grab this static object and insert it into my particle sim. So let's see if this works. So this way we should get even more of the motion kind of fixed or sorted out ahead of time. Before, I think we were having, one of the issues was that too much of our motion or smoke velocities was baked in and already like going through the car. So that gave us the illusion that things were even worse than they, like our collision looked like it wasn't working because of that. Another thing I might do is decrease our life expectancy even more. So we could try this. I've just been pretty lazy. I've been killing this stuff after like 30 seconds or something, but it seems to be pretty quick to run. So I'll get some water. I'll be right back in a minute. Made you pick up Houdini again after all the years of absence? How long of an absence did you have from Houdini? So we have like 5 seconds of cache. Should be good now. 12 years? Oh my god. What you were doing were you doing the old interface of Houdini where the nodes were like big blocks? The square shaped nodes? When you mentioned that, yes, it probably is. So it looks like we're getting a bit more interaction with the vehicle now that we sorted out our collisions to happen earlier within the particle simulation stuff. I don't believe the bounds are set to close. That's a good catch. We have a leak in our container. So those boundaries just set this negative y. This bottom face will be treated like a ground plane. You can add a ground plane, but I've found that this just setting that face closed tends to give you like maybe better performance or better accuracy. So that should help us with our velocities. Instead of stuff being able to escape at the bottom of our container, we should just have more interesting motion and stuff overall. You went into architecture and design many years ago, so you're stuck in Autodesk. You were doing Revit? We might want to increase the velocity. I'm gonna go ahead and do that. Every architect that I knew was using Grasshopper like in school and doing really fun stuff, and then when they got a job they just had to do Revit, and they always said it was just the worst and really boring. But the ACAD, did you do Form Z? Form Z is like really too old, right? So I'm going from 25% to 75% of the source velocity. You dodged the Form Z bullet? Yeah, I think that was like before everyone's time. Like that was professors that were like really old that were using that. But this is the Grasshopper stuff. The Grasshopper is like a plugin for the Rhinoceros NURBS architecture stuff. And they do some pretty cool stuff with it to do like the very procedural. The architects call it parametric for whatever reason, because they think they sound fancier when they say it. But it's the same idea. You can do kind of Houdini type stuff with architectural things. It's pretty cool. I went to a talk for this, but I didn't know Rhinoceros at all, and like I tried to follow along and I didn't make it very far. So we might have gone too high with that upwards trajectory on our the source like velocity or whatever on the particles, but one thing we can do is maybe just add more turbulence to kind of break that up. So we'll do maybe 8, and I'm gonna increase the frequency a little bit. I might increase that turbulence as well. So we have two different turbulences. One is like the source turbulence that just gets added to the source velocity vectors. And then I have my kind of main gas turbulence VOP that is added everywhere that we have a density that exists. Revit is mainly about BIM capabilities, not design per se. Yeah, I know some architects that work at some of the places that do the office conversions and stuff like that, like Industrious or all of those companies. It seems like screw Autodesk and all your on what you're showing. Yeah, it seems like I don't know, some architects are not, I don't know. It's possible that as an architect you have spent you could have been spending the last like 5 years basically converting existing real estate or warehouses or things like that into open floor plans for WeWork or Industrious and all those companies to buy them up and rent them out to people. And then in the last 5 months, because of the quarantine and everything, they've basically said, stop doing open floor plans, do closed floor plans, make dividers. So you just spent the last like 5 years doing everything one way, and then you now need to turn around and do it completely different. You going to bed, Alex? Have a good night. Thanks for staying up so late. So this turbulence frequency just seems a bit too low. I'm gonna just go in and hammer this. So the noise on the curl noise and the swirl size kind of work. They're like inverse of each other. You have to be a bit careful when you're adjusting them, but swirl size, you want the numbers to be bigger to have larger features get introduced. And then the frequency parameters on the curl noise, you want those numbers to be smaller to produce bigger features. 180-degree reversal. Yeah, I kind of came upon to that realization sometime in the last few months, and I was like, man, that has to be a bummer. Or it's like people's entire careers or educations were like centered around making open floor plans, doing acoustics, and like there's a lot of airflow, like ventilation, there's a lot of thought and design and stuff that goes into that stuff, and now it's immediately like reversing or switching. So I think my turbulence VOP, the turbulence inside of the network, is too strong. You could also like change this threshold so you're only adding turbulence to high density areas. This is just a Boolean, like it will either happen or not. You can do control settings. One thing I usually like to do is I'll do a copy of this density node, and then I'll use this to source to temperature. And the reason to do that is because using your temperature field, you can diffuse it, you can cool it, you can use it to change buoyancy. But because of this cooling rate, the temperature field will be decreasing by half every frame. So if I go to my control settings here on the turbulence and just say add turbulence where the temperature is 1 and add less turbulence where it's 0, then I'm able to more specifically control where a lot of turbulence is added. I'm gonna go a bit lower with it as well. AHS ADA regulation, driving every 9 years and doubling overtime in the past couple of months. Yeah, it seems like with a lot of the AutoCAD and that kind of architecture engineering and stuff, like a lot of the professional tasks revolve around just working around the codes and regulation. I don't know, that's why I enjoy a lot of the Houdini stuff, because it's like no rules, just it's all just about creativity, and it's just about what the results you get and like how visually it looks. Like nobody's gonna audit your hit file and make sure you follow the regulations. So basically, I'm trying to get rid of this persistence kind of bubbling and roiling and stuff like that. But it looks like I kind of went maybe a little bit too far. I'm gonna press escape. I'm gonna go up here. I'm gonna try something like that. Yeah, it's nice to have the freedom with stuff in Houdini. Sometimes I feel like there's a bit too much freedom. Like sometimes there's just too many different ways to do things that you don't know which way. It just becomes a bit intimidating, or especially for new people learning it, it becomes a bit confusing. I don't really use shred. I've never really used it that much, Chris Arn. So with this turbulence working a little bit better, I'm starting to break up some of those shapes. So if we want more kind of overall expansion of stuff, I'm just gonna boost this source turbulence that we're kind of just adding in the source area. Might go all the way up to 20. So basically, when this smoke is created from the particles, I just want it to be injected at a higher velocity or shot out stronger. So instead of the more directional motion we were getting before, this source turbulence that we added to those particles should just expand or billow out this stuff in much more like unidirectional instead of being at like upward direction. So if we go back to this thing here, like you can kind of see it. Some areas it has some directionality to it. I don't know what's going on, like if that's his exhaust pipes or something. Kind of like a rocket on a launch pad getting ready to take off. I don't know what's... It's like you need 4 different setups or 4 different sources to do all the different stuff. But I'm trying to get the circular, that kind of stuff going right now. But yeah, I've never really used that grass shred stuff too much. When I was first... Yeah, I don't know. I've never found it to be that. At the start when I was using gas stuff, I tried it, but I never liked it too much. If I'm interested in kind of shredding or making the velocity like a little bit more gnarly, I'll usually start with just the gas vortex confinement. This one seems a bit more kind of grounded in reality. I don't know. Like it's kind of trying to preserve swirls and stuff like that. The shred is doing some stuff based off of like the gradient. I don't know. Yeah, it's. I think it also it's also running maybe based off of VOPs, so it doesn't work that well with OpenCL. Maybe they have it working better with it now. But yeah, I don't know. I just don't really like to use it that much. The vertical particles you're talking about? Sometimes I'll do this repeat solver So this is adding like several iterations of vortex confinement. I've tried the vortical particles and stuff like that before. It seems kind of valuable, but it's always like it adds a lot more stuff to tweak. I feel like where instead of I don't know, it's just at a certain point you're kind of managing like too many different settings or aspects of things. So this is the difference here with the vortex confinement stuff. I might not have enough resolution to really see a difference with it. Like it looks a little bit different, but it's hard to tell exactly what's going on. The last thing I would add would be the disturbance for like the really fine kind of details and stuff like that to break up some of these pressure fronts. So this vortex confinement, it looks like it's making things a little bit kind of enhanced, or it's getting rid of some of the larger scale like ink look of things. It can enhance some of the little swirls a little bit better. All right. So this turbulence, I'm going to jack it all the way up a bit higher because I have it masked by the temperature. I might make the minimum like 0.1. What I'm hoping to do with this is just inject more motion and more turbulence into this kind of section of things, but hopefully the temperature cools down fast enough and it's not lingering around forever. So by injecting more turbulence into things, you should get overall like an expansion kind of motion, just because things are being pushed in all sorts of directions. So I might have done a bit too much. I might go a little higher with the swirl size. And I'm gonna get rid of this vortex confinement for now. We'll do some of the disturbance. We could just make sure to link this. I usually like to do, I don't know, I'm always doing OpenCL anyways, but I usually just a habit to make that an expression. That if you were watching the cloud sky stream I did on Wednesday, I think, I went over this turbulence and the disturbance in a little bit more detail. But I usually like to add this based off of the pressure control field. The pressure field is output by the pressure solve. So inside of this smoke solver, there's this project multigrid and stuff. If you look at this, it says the pressure required to make the velocity field divergence free is output into this field. So that's just for, it's kind of like if you do vellum, you get some output energies, output attributes of like energy, or it's just a useful kind of thing that gets generated by the pressure solver. So we can use it to mask and only apply disturbance in certain areas. I think I forgot to adjust my disturbance size, like that block size setting of it. So I'm just going to go in and do that. I think it's super big right now. So in that clouds thing I said, usually the division size, copy that. Vegan nuts. Thanks for hanging out. Yeah, so my base block size was too big by a factor of 10. So I think that block size being too big was what was making that thing shoot all the way up. So I don't know generally, like visually, what people are referring to if they say shredding, but if you're looking for really fine, like kind of pyroclastic or fluffiness, this disturbance I've usually found is the most reliable way to add that stuff to everything. So it's just taking the velocities around the areas that are getting pushed outwards, so that anything that's getting pushed or moved generates pressure, and then based off of that pressure we add disturbance to things to without disturbance you just have this low kind of resolution, or it's like ink and water. This disturbance just kind of adds like the natural with air or moving particles or things like that, like there's always subtle little differences in the air things aren't perfectly smooth. So to replicate that with computer graphics, it's just using this disturbance is a good idea. So it looks like my turbulence is just sticking around too long. And then the scale of it might still be too much. So I might try that. I'm also, if you want like a nice fluffy look, sometimes making the density stronger and then the shadow density lower, then you will just start to get more light bleeding into the shadows, like just a more it's kind of like, it's the cheapest way to simulate kind of volume bounces without doing really expensive operations of rendering stuff. So we might have, I don't know, maybe having the particles like collide with the car for too long, we're getting this weird upward motion. This might also just be based off of our turbulence. Like the stuff in the back is looking pretty realistic and pretty nice. I don't know, that thing right there is a bit odd. Should you double check your temperature field to make sure your cooling is right? I'm going blind. I'm doing a lot of things blind. Yeah, that's a good idea. So I did the same thing with the pressure field. I just typed in numbers without checking it. So if we do temperature, I could just go to maybe frame 31 or something. So we're just gonna double check that the band or the area of the simulation that I'm injecting turbulence into is what I think I'm doing. We might have 10 more frames or so to go. Sometimes it's what I've also done to debug or check fields are doing what you expect to do is you could change your domain and just like crop it to one tire or a subset of the domain, and then you can more quickly kind of inspect things. So I imported temperature, but it doesn't get visualized right now. So that's just because this pyro post process is bound to density. You can just use the name node and rename that if you want. But you could also just do a volume slice. And this is the best way to inspect values if you're really using them to drive other fields and stuff like that. You don't really care too much about the visualization or how pretty they look. You just care more about the values. So Steve is talking about this temperature range. I've remapped from the source to be take 0.35 as the minimum and 1 as the maximum. So I can do that same kind of visualization here and do 0.35 to 1. So this is roughly the areas that I'm injecting turbulence into. What do you think? I could do maybe a little bit less. It seems like I'm close. It might be a bit too much. It's kind of hard to visualize it using this slicer. Another method you can do is like convert VDB. Go from the DOPS always works with regular Houdini volumes. You can't ever use VDBs inside of here. It will always get converted to a standard Houdini volume. So we need to go back to VDB, and then we can do this VDB visualize tree. And instead of the leaf nodes, we can just make points, not tiles. We want to do voxels. And then we don't need to color them, but when it generates these points, we need to do points with values. Then we get this VDB float. So that's the value at the current field, like at the current voxel position. And then we can do ramp from attribute. We just grab that VDB float, and this is our temperature. And if we want to visualize it, we could do that same infrared stuff if we want. It's a nice trick. It's just a veteran move. So instead of doing a slice, we just have a 3D visualization. We're doing 0.35 to 1. Do 0.35 to 1. And if you want to be like extra specific, you could do at VDB float is less than 0.35. So these areas specifically is where we're injecting turbulence. The red is full turbulence, and infrared value is rolling off to be less turbulence. So if you're ever making a demo reel, you can just cut together a lot of visualization passes like this, and you'll get a job as an effects artist. I feel like that's not even a lie. Like, if I was making a demo reel right now to get hired, I would just do something with like 20 different, the breakdown would be like 20 different visualizations. So I think I might go a little bit higher with this. So I'm going to do more turbulence, but just at a higher temperature value. There's other ways you can change that temperature field. I could increase cooling or change some of that other stuff. And then I might just do a bit less turbulence to the source particle velocity, and the main velocity I'm going to bring it in at the full strength. So my thinking here, my thought process is I want to preserve more of that directionality of things. Then I also want to get rid of temperature and go back to density. The density field doesn't cool or doesn't fade out over time. For car smoke, I don't know, it feels like you'd have to be sitting around for a long time for it to completely fade out or dissipate or whatever. To display anything remotely like that using Autodesk, you need to buy 10K CFD analysis package. Autodesk has some really interesting like screenshots I see of the CFD and FEM things. Like the visualizations look really cool, but I never have any idea how long that stuff takes to simulate or like how expensive the licenses are. But sounds like it's an investment. So if you want to keep inspecting the temperature, you can always just do like an object merge. I usually just link up the path like that. So this will bring in the temperature field as well. And then we'll just play it again. My light, oh no, it's working. I thought I still had that headlight on. So I'm hoping to get rid of that like weird directionality of stuff. It's like a punch going forward or something. It's just a bit odd. But if it still persists, I think it's baked into the particle velocities, because it's like ricocheting around the wheel well there and then sliding forward. But the back area, we'll hope that improves. I think that the turbulence stuff is working a little bit better. It's hard to tell. I think this is, maybe it will disappear if the vehicle starts moving. Yeah, I'm not too concerned about that. I'm pretty sure it is baked into the source particles. Like if I look at them here, I think it's those things right there. I didn't record enough attributes, but like I could just probably go in and address it right now. But basically with this like life expectancy, if I go very low, want to reset that. Then we can kill them before they go too far up the wheel well, like that. There's other things you could do, like you can add these hit attributes, and then like if it's colliding or if it's been colliding for too long, we could delete it. Let's maybe keep them a little bit longer. You still want a little bit of that like scoop motion of things, but It was just way too much before. The more you reduce the life, the faster your particle simulation will go, because it's just like less particles to keep track of, less operations and stuff. We're gonna be down to just like a 10-second particle simulation before we know it. We're just simulating like 2 frames. You could do you could probably just replicate this with like guide geometry and make a procedural source, but I tend to prefer to work with like a simulation, just because it tends, like, you seem to be able to get more detail and interesting kind of turbulence and stuff based off of it. Alright, so we got 80 frames done. What I might do as well is you do get spikes unless you can hide them. Yeah, the spikes you were seeing is a bit odd. That is something we should look at to try to fix them. There are some ideas I have of like looking at seeing if particles find nearby particles, and then you can get the weird ones that shoot off like that if you want to. I think that's what you were talking about, right? So I'm just going to make a camera in the scene and do a circle. Yeah, you tend to get the spikes. So I don't know what the best strategy is that you could get rid of the ones that are by themselves like that. Another thing is you just need more of them, and then you need to be sourcing them at like less strength. So eventually you get just like kind of like a contrast or whatever, like then the lone ones get weighted to be smaller or less apparent. So we're making a classic turntable rig right now. So I think under constraints, you can just do follow path. So now I just select this. Oops, we did it wrong. We want the camera, follow path, select the path object. Then I don't need any look at. What is happening? Did it do it? I feel like these constraint stuff was kind of a... Let me just turn that off right now. What the hell is going on here? Oh no. Oh no. Let me save the scene. Do you guys still use the constraint stuff? It was working. And then I just need something for it to look at. I'll just put a null in the center, go back to constraints, grab the camera, look at object, look up. We don't need that. All right. We should be back in business. So I'm just gonna pin the view inside of here. Then if I go into the constraints network, this follow path, you can just animate this. I think you need to Might just do it with this expression. I'm sorry, with a keyframe. Because I was enjoying this kind of angle at the start. Could just parent it to a null and rotate it. Yeah, that's a bit more reliable, I think. I'm gonna turn off the simulation for a second, like turn my brain off. Turn off the dynamics. I might just want to go a few degrees. I was also sneaking into the I just want to do a linear interpolation or whatever. Sometimes when I was lazy, I was going into the camera, and if you do like invisible parameters, then it still has these path things that you can type in. It's like I feel like they shouldn't have depreciated that. I don't know. It's okay. All right. So we have our new camera turntable. We have our new particle simulation. It's going to take a minute it has to calculate the collision geometry for the car. But basically we should have fixed that punch. So I think this is a bit weird because I'm visualizing the car with that tire that I didn't rotate. It's just for visualization, it doesn't affect the other stuff. It's still getting a little bit too strong of velocity there. Maybe my lifespan was still out of the range. But it looks like decreasing that life did fix the spikes. I think the spikes were just from particles living too long. And I think my disturbance might just be a bit too strong. I'm gonna go to 10 for that. I'm gonna start moving to a higher resolution. Give it a go. So I'm getting close to wrapping things up for today. So I just wanted to boost up the resolution and just see what it looks like with a bit more detail or accuracy. Nice long stream today. Sorry about the disconnection mishap. Yeah, so the goal today is just to get the car imported, get our minds wrapped around how to kind of work with that, split it up and stuff. Animations, I guess I should have been flipbooking with the wheels spinning, but sorry about that. Bringing in the great content, top tier sneeze. So bringing in the wheels and how we would get the velocities set up. It looks like moving to a higher resolution, we're capturing the collision geometry a bit better. So we're just more accurate airflow within the collision geometry. But yeah, just a first pass kind of doing I'm calling this look dev, even though we're doing effects or simulation, but we're just defining the motion and the look of the smoke. And then if we move to an animation, maybe he'll do a donut, or we'll go into that figure 8. The figure 8 stuff was really interesting, actually. I think it was Billy that had brought that up. It's like this Vimeo one right here. But yeah, there's some really nice fluffy kind of details happening with this one. Gesundheit. Enhance. 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 We're still working at a pretty fast pace. Maybe like a couple seconds, 3 or 4 seconds per frame. It's nice on dirt when it shoots back and then calms down. You're talking about the stuff in here, or you have a different reference in mind? I think the other stuff with dirt that gets pretty interesting is the color mixture, like brown to white. You might be able to just fake that with like doing a ramp on your density or temperature map. But yeah, it just seems like with smoke, like even dust explosions or stuff like that, just having a bit of like black, brown, and white smoke makes things look like 20 times better than just a single color. Rather than just burning rubber if it's kicking dirt around. Yeah, I guess that's the main difference between this and the Ken Block ones. They must, I don't know, I was watching other references and it seems like sometimes people put like flares or like chalk or something in the tire or the wheel well to get different things. We're starting to get some of that stuff sliding out. His was pretty ridiculous. It was like a rocket taking off. Like he must have had like a fog machine underneath, or like something was happening with his exhaust pipes, or he had more pipes or something like that. He added leaf blowers underneath. Yeah, so someone at the very start of the stream was saying to decrease the stuff at the start of at the front of the car. I think just for aesthetic purposes, that's probably the best idea as well. Like not even from a physics or accuracy standpoint, but just seeing a car visually, it seems like you expect to see, or it looks better to see smoke only coming out of the back wheel wells or whatever. Or more smoke, bigger pops or whatever. Yeah, I don't know, the front wheels got a bit too spiky, but this back stuff is feeling pretty nice. It's a start. It's something. It's progress, yeah. So hopefully tomorrow we'll move into just getting some more interesting like motion. I feel like once you have the car moving around or doing something, you start to get better results or just more interesting performance. But this reference here was a pretty good one for like how to make a static car still have an interesting. I guess he starts moving at the end. I feel like this is one of the, oh, he is kind of shaking around or something. It's like he's tied. It's an animal tied up. This shot's pretty cool. This would be a cool one to, yeah, it looks like he is. He's on like a rig or something like that. Yeah, it's like a wench or something. Spinning all 4 wheels. I feel like this is something where there's certain references or effects where you get them and you're like, whatever I try to do to replicate this in CG, it's not going to look real. And that's kind of one of them, is like just having a car staying still, making a lot of smoke is, I don't know, it's always going to just be a bit of a weird concept to try to do in CG. The back is feeling pretty good. It's interesting. You might want to do maybe some more turbulence in like that lower range. This stuff is slowing down a bit. But the other thing you can do is just bring in that temperature field and use it as like a density if you want stuff fading out quicker. But his smoke was staying around pretty long. But yeah, to start, so probably move the Alembic that I'm using for this car into the stream directory, so you don't have to worry about getting it. It's just from that Arnold link that I put at the top of the chat. You might have to go to a previous VOD if you're watching this, because we had the stream drop out or whatever in the middle. But at this, if you go to the previous thing, you'll see the link for that Arnold learning scene. That's where this Lamborghini is from. You'll need it if you run through this, because the velocities and everything is kind of based off of that geometry. So yeah, we're probably going to end it here. Be putting the files. We'll just save this. Files in the Discord. Thanks everyone, bearing with me with this technical difficulties. Yeah, of course. Thanks everyone for hanging out and the advice, the references, and the chatter.